This video is Momentum and Collisions 1. An equation for the conservation of total momentum is the initial momentum is equal to the final momentum. Actually, in my mind, that's more of an idea than an equation, but the idea is whatever momentum you start with, that's the momentum you have at the end. And this equation holds only if the net force on the system is 0. There can be forces within the system, internal forces, but the net force on the system has to be 0. There are 3 types of collisions: elastic, perfectly inelastic, or partially inelastic. An elastic collision is one in which mechanical energy is conserved, momentum is conserved, and the objects bounce off of each other. Let's skip over to partially inelastic collisions. In a partially inelastic collision, the objects also bounce off of each other and momentum is conserved, but mechanical energy is not. In a perfectly inelastic collision, the objects stick to each other. There are other terms besides perfectly inelastic. Sometimes we use the term totally inelastic or completely inelastic. But there's got to be some term before the word inelastic that indicates complete inelastic collision. Those objects are going to stick together. They don't bounce off of each other. Momentum is conserved, but mechanical energy is not. What these have in common, you can see, is that in every case, momentum is conserved. In an elastic collision, which in the macroscopic world is a comparatively rare thing, although for gas particles at reasonably low pressures and high temperatures, elastic collisions are pretty well satisfied. But in the macroscopic world, in the observable world, an elastic collision is a pretty rare thing. But mechanical energy is conserved, the objects bounce off of each other. Usually in the macroscopic world, when objects bounce off of each other, it's a partially inelastic collision. Momentum is conserved, but some of the mechanical energy has been turned into thermal energy. And we'll try to elaborate on that here with this example. So what we have here is we have the 3 types of collisions: elastic, perfectly inelastic, and partially inelastic. And we've got some kind of a rubber ball, perhaps, approaching a wall. And we want to show what happens to the energy as the ball collides with the wall and then what happens next. So in an elastic collision, this ball, at the instant it's here on the wall, that 5 joules of energy is elastic energy. It's stored for an instant. And we have, of course, no kinetic when the ball is stuck to the wall there. Then with an elastic collision, this ball bounces off, and once again, it has its 5 joules of kinetic energy, and it has no potential. We're just making these numbers up. But for an elastic collision, that's what happens. The kinetic energy is conserved. In a perfectly inelastic collision, that's where the objects are going to stick together. Right here, at the instant that this hits the wall and sticks, perhaps this is a blob of clay, there's still a little bit of elasticity, it looks to me. So we might say, you know what, maybe there are 3 joules of potential energy that are stored there. Again, we're just making these numbers up. Maybe 2 joules have turned into thermal energy. Then this object will kind of come back to its normal shape, but it will still be stuck to the wall. And in that case, then, all 5 of those joules have turned into heat. Let's try the intermediate example. The elastic and the perfectly inelastic, or totally inelastic, or completely inelastic, those are kind of the extremes of the spectrum. And a partially inelastic is somewhere in between. We're going to have this object bounce off at the end. So I'll go ahead and draw that in before we put numbers of joules in. But kinetic energy is not conserved. So when it comes off here, it's not going to have the same kinetic energy that it had before. Let's just make up a number. Let's say that maybe it has 3 joules of kinetic energy, and 2 of those joules have turned into thermal energy. When it's sitting right there, obviously it has no kinetic energy because it's not moving. Maybe 2 of the joules turned into thermal energy, and at that instant it has 3 joules of elastic potential energy. So we're going to deal with these types of collisions as we talk about conservation of momentum.